Okay, Passport to Advanced Math Lesson 4 is all about solving equations involving radicals. This is Standard 7 within the Passport to Advanced Mathematics section. And let's define what a radical equation is first. A radical equation is an equation as a variable as part of a radicand. All right, so basically, if I have something like the square root of x plus 3 equals 5, in order to solve this equation, I would have to get rid of the radicand to get x by itself. So to solve these, right, first thing we're going to do is isolate the square root, meaning get it by itself on one side. Then the inverse operation of the square root is the exponent 2. So if I have the square root of a, right, to get rid of the square root, I could take the square root of a, square it, and it would just leave me with a. Now, sometimes when we do this, remember what we do to one side, we do to the other. And once we get rid of the radical, we'll still have an equation to solve. That equation right now for most of these will either be linear or quadratic. So you're going to solve the remaining equation, and then you have to check for extraneous solutions. All right? If you don't know what this is, these are solutions you get algebraically, but don't make true statements when you plug them back in. Now, knowing how to solve these radical equations is important, but sometimes on the test you'll forget or you'll have like a brain freeze. So one easy strategy to help you if you ever do forget is plug the answer choices back in to see which ones give you a true statement. Okay, so I'm going to do some of these both ways, right? Now here, when I look at the first one, what are all the values of x that satisfy the given equation? They want to know if it's 1, 9, or both of these, or neither of those. Now, solving this isn't hard, right? I could go ahead, square this side, but then I would have to square this. Now remember, when I square the right side, the left side, I get 4x equals. When I square the right side, I would have to FOIL that out. It's not that it's hard, but the easier approach to this problem would be to take each of these answer choices and plug them in. So I'm going to take 1 and I'm going to plug it in. The square root of 4 times 1, does that equal 1 minus 3? Well, that gives me a square root of 4 equals negative 2. Is that true or false? That is false. Therefore, that can't work. The next one, right? If I plug 9 in, the square root of 4 times 9, does that equal 9 minus 3? Well, the square root of 36, does that equal 6? You better believe it. So 9 is a solution. So 1 only can't work, right? 2 only could work because 1 and 2, both of them don't work and neither cannot be a choice. So your answer would be B. The next one, in the equation above, k is a constant. If x equals 9, what is the value of k? Now, here's the thing. They kind of try to trick you here, but they tell you x is equal to 9. So what I'm going to do is substitute that value in here. So the square root of k plus 2 minus 9 equals 0. Now, you could easily plug these answer choices in. For this one, it might actually be easier to solve. So first thing I'm going to do is get the radical by itself. So the square root of k plus 2 equals 9. Now to get rid of the radical, I go ahead and I square it. And I get k plus 2 is equal to 81. Now subtract 2, and k would equal 79, which is letter D. Is there anything wrong with plugging it back in? No. The square root of k plus 2 minus 9 equals 0. So now, if I plug these values in, 1 plus 2 is 3. The square root of 3 doesn't come out even, so I know that's not going to work. 7 plus 2 is 9. The square root of 9 is 3. 3 minus 9 is negative 6. Does that equal 0? Nope. 16 plus 2 is 18. The square root of 18 isn't going to come out even. And then when I put 79 in there, 79 plus 2 gives me the square root of 81 minus 9. Will that equal 0? Yes. So you could plug the answers in to find that. So now the next one. If k is greater than 0 and x is equal to 7 in the equation above, what is the value of k? So again, now I'm going to substitute 7 in for x. So the square root of 2k squared plus 17 minus 7 equals 0. Now again, it's not that this is a hard equation to solve. Okay, but if you wanted to, you could plug the answers back in real quickly. So let's try that in our head real quick. If I put 2 in, 2 squared is 4 times 2 is 8 plus 17 is going to give you 25. Is the square root of 25 minus 7 going to give you 0? No. Now, 3 squared is 9. 2 times 9 is 18. 18 plus 17 is 35. You know that's not going to work, right? And then when I get down to it, 4 squared is 16. 16 times 2 is 32. 32 plus 17 is 49. The square root of 49 is 7. 7 minus 7 will give you 0. That would work. So you know 4 is your answer. Now, if I did solve it by hand, I would say 2k squared plus 17 equals 7 because I'm going to add 7 to both sides. Now, I'm going to square the left side, square the right side. 2k squared plus 17 equals 49. Subtract 17. 2k squared equals 32. Divide by 2. K squared equals 16. Now I can take the square root, and you would get plus or minus 4, but 4 is the only choice there. All right, the last one here. Again, I know when I square this here, I'm going to have to FOIL that out and solve a quadratic. So I'm actually going to just go ahead and substitute values in. It says if a equals 2, what is the solution set for the equation above? So the square root of x minus 2 equals x minus 4. Now, I know 3 and 6 both have to be plugged in, so I'm just going to go ahead and do that. The square root of 3 minus 2, does that equal 3 minus 4? Well, the square root of 1 is 1. Does that equal negative 1? No. So you know 3 doesn't work, which means that won't work either. Now I will try 6 next instead of 2, because I know 2 minus 2 is 0, right? 2 minus 4 is negative 2. So just by common sense, I know that isn't going to work. So the square root of 6 minus 2, does that equal 6 minus 4? Well, this gives me the square root of 4 equals 2. 2 equals 2. So 6 makes that equation true and is your only solution. Okay, 3 would be what we call an extraneous solution.